Today we are going to discuss about some problems related to the fluid properties. Please note down. Calculate the specific weight, density and specific gravity of 1 liter of liquid which weight is 7 newtons. Calculate the specific weight, density and specific gravity, and also they have given 1 liter of liquid. That means volume is given, volume is equal to 1 liter, and also weight of the liquid also given, that is 7 newtons. Weight W, that is equal to 7 newtons. Given problem, they want to determine the specific weight, density and the specific gravity of the liquid. They have given volume, that is equal to 1 liter, and the weight of the liquid also given, that is 7 newtons. First, for the determination of specific weight equal to weight by volume. Specific weight equal to weight by volume. But weight is given, that is in newtons. Volume is given, that is in liters. First that converts into meter cube, that is equal to 1 into 10 power minus 3 meter cube. Right? Therefore, specific weight, small w is equal to weight divided by volume. Weight is equal to 7 newtons divided by volume is 1 into 10 power minus 3. 1 into 10 power minus 3. Therefore, specific weight is equal to, from this value, specific weight equal to 7000 Newton per meter cube. Right? Second question. Density. Already I have given the relation between the density and specific weight. Specific weight equal to density into acceleration due to gravity. Right? Now density rho equal to weight, unit weight divided by acceleration due to gravity. Unit weight already we have determined here, that is equal to 7000 Newton per meter cube divided by gravity, that is equal to 9.81. Therefore, density of the liquid equal to 713.5 kg per meter cube. Right? We have determined the density of the fluid also here. Now, what is the specific gravity? Next question, what is the specific gravity? I have given one relation, that is specific gravity equal to density of the liquid divided by density of the standard liquid. Standard liquid. Density of the liquid already we have determined here. Density of the liquid already we have determined here. Density of the standard liquid, that means water. Water density is 1000 kg per meter cube. Density of the water. Density of the water. Water density rho equal to 1000 kg per meter cube. Therefore, specific gravity of this liquid is equal to density of the liquid. What is the density of the liquid? That is already determined here, that is equal to 713.5 divided by density of the standard liquid, that is the water. Water density is 1000 kg per meter cube. That is equal to 1000 kg per meter cube. Therefore, specific gravity of this liquid is equal to 0.717. Right? This is one formula for the determination of density of the liquid, and one more formula, and also specific gravity, one more formula. Specific gravity is equal to unit weight of liquid, that is unit weight of liquid divided by divided by unit weight of standard liquid. Unit weight of liquid already we have determined here, that is 7,000 Newton per meter cube, divided by unit weight of standard liquid, that is water, unit weight is 9810 Newton per meter cube. Therefore the specific gravity is also same value, we are going to get it, that is equal to 0.717. Right? Right, now we are going to discuss one more problem related to fluid properties. Please note down. Calculate the density, specific weight and weight of the liquid and weight of 1 liter of petrol of specific gravity 0.7. Right, calculate the density, specific weight and weight of 1 liter of petrol. And weight is different from specific weight. Weight of 1 liter of petrol, that means volume is given, that is equal to 1 liter. 1 liter of petrol of specific gravity is also given, specific gravity equal to 0.7. Right, here we are going to determine what is the density of the fluid, what is the unit weight of this fluid, what is the weight of the fluid. Here volume is given and specific gravity of the fluid is also given. Right, now for the determination of density, right, we know one formula, specific gravity equal to unit weight of liquid divided by unit weight of standard liquid. Unit weight of liquid divided by unit weight of standard liquid. Now unit weight of liquid, in this problem the liquid name is, so here they have given petrol. Now we are going to determine the density of the petrol, unit weight of petrol and weight of the petrol. But the petrol is volume given, the petrol volume is given, that is 1 liter, and also specific gravity is given, that is equal to 0.7. Now specific gravity of any liquid equal to specific weight of that liquid divided by specific weight of standard liquid. Now specific gravity of petrol is equal to specific weight of petrol divided by specific weight of standard liquid. Right, therefore specific weight of petrol equal to specific gravity of the petrol into unit weight of standard liquid. Right, specific gravity of petrol given in the problem, that is equal to 0.7 into specific weight or unit weight of standard liquid, that is equal to unit weight of standard liquid means water, unit weight equal to 9810 Newton per meter cube. Therefore 0.7 specific gravity into 9810 Newton per meter cube. Therefore specific weight equal to specific weight of the petrol or specific unit weight of this petrol is equal to, right, now specific weight of petrol equal to 6867 Newton per meter cube. Right, now we are going to determine the density of the petrol. I have given one relation, unit weight equal to density into acceleration due to gravity. That means unit weight equal to density into acceleration due to gravity. From this equation, therefore density rho is equal to unit weight divided by acceleration due to gravity. Unit weight that is calculated here, that is equal to 6867 Newton per meter cube divided by acceleration due to gravity, that is equal to 9.81. Therefore density of the fluid from this one, density of the petrol equal to 700 kg per meter cube. This is also clear. Now we are going to determine the weight. But we have one equation with respect to weight. Unit weight equal to weight by volume. Unit weight equal to weight by volume. That is, unit weight equal to weight divided by volume. From this equation, weight equal to unit weight into volume. Right? Therefore, weight of the liquid or weight of the fluid, weight of the petrol equal to unit weight already we have determined. That is equal to unit weight already we have determined. That is equal to, this is the value. That is 6867 into volume. Volume is given in the problem, that is equal to 1 liter, that converts into meter cube. 1 into 10 power minus 3 meter cube. Therefore, here 1 into 10 power minus 3 meter cube. Therefore, this is equal to the weight of the petrol equal to 6.867 newtons. This is the value. Right? Now we are going to determine one more problem related to the fluid properties. Right. Please note down. A plate, this problem is related to the viscosity. Please note down the problem. A plate 0.025 mm. A plate 0.025 mm distance from a fixed plate. Suppose this is one fixed plate. Moves at 60 centimeter per second and requires a force of 2 Newton per unit area. A plate 0.025 mm distance from a fixed plate. The distance from the fixed plate is 0.025 mm. 25 mm distance from a fixed plate. Move at 60 centimeter per second. Velocity is given, that is equal to 60 centimeter per second, and requires a force of 2 Newton per unit area, that is equal to 2 Newton per meter square. That means that the stress is given, that is equal to 2 Newton per meter square. To maintain the speed, determine the fluid viscosity between the plates. What is the viscosity between the plates? Right, this is the problem given here. In this problem they have given one fixed plate. The distance from the fixed plate is one more plate, that is the distance between the fixed plate and the one plate is 0.025 mm. The velocity of the plate moving at a distance of 0.05 mm, that is equal to v is equal to 60 centimeter per second. To maintain the speed, they have applied some force, that is equal to 2 Newton per meter square. That is nothing but shear stress here. Find the viscosity. But we know one standard formula, shear stress equal to mu into du by dy. Right. Now what is the shear stress? They want to determine the viscosity. Here they have given shear stress. What is du? What is the velocity here? What is the change in velocity? In this problem, the velocity of plate is given, that is 60 centimeter per second. But the velocity over the fixed plate is 0. The velocity over the fixed plate is equal to 0. The velocity of plate at a distance 0.025 mm from the fixed plate is 60 centimeter per second. First, this velocity is converts into meter per second, that is equal to 60 divided by 100 meters per second, 0 0 cancel. Therefore velocity of plate is equal to 0.6 meter per second. Now the velocity of fixed plate V is equal to 0. The velocity of the plate is 0.6 meter per second. Therefore change in velocity du is equal to plate velocity here. That means this is the velocity gradient. Here having velocity 60 centimeter per second, here having velocity 0. Therefore change in velocity is equal to final velocity, that plate velocity 0.6 minus 0 equal to 0.6 meter per second. This is the change in velocity. And the depth dy, the distance between these two plates, that is given dy equal to 0.025 mm. First that converts into meters, that is equal to 0.025 into 10 power minus 3 meters. Now we want to determine what is the viscosity of the fluid. We know one standard formula, shear stress tau is equal to mu into du by dy. I have derived this formula in the earlier class. Based on this equation, we are going to determine the viscosity of the fluid. Now shear stress is given, that is equal to 2 Newton per meter square. 2 is equal to mu, that is the viscosity is the unknown, into du, change in velocity, that is equal to 0.6 divided by dy, that is the given, that is equal to 0.025 into 10 power minus 3. From this equation, the viscosity of the fluid mu is equal to 8.33 into 10 power minus 5 Newton second per meter square. This is the viscosity of the fluid. Now we are going to discuss one more problem related to the viscosity. A flat plate of area 1.5 into 10 power 6 mm square is pulled with a speed of 0.4 meter per second relative to another plate, 0.14 meter per second relative to another plate located at a distance of 0.15 mm from it. Find the force and power required to maintain this speed if the fluid separating them is having a viscosity as 1 poise. A flat plate of area 1.5 into 10 power 6 mm square. Area is given 1.5 into 10 power 6 mm square. Is pulled with a speed of, velocity is given, that is equal to 0.4 meter per second relative to another plate located at a distance of 0.15 mm, that is equal to dy is given, that is equal to 0.15 mm. Find the force F is equal to what? And also power required to maintain the speed. If the fluid separating them is having a viscosity is given, that is equal to, viscosity mu is equal to 1 poise. 1 poise. Right, for the determination of force, we should calculate the stress. That is the shear stress. We know one standard formula, shear stress tau is equal to mu into du by dy. Shear stress tau is equal to mu into du by dy. Here viscosity is given. Mu is nothing but viscosity. Du, change in velocity. Dy, depth between two plates. Therefore viscosity equal to 1 poise. 1 poise means, poise is the units of viscosity in Celsius system. Now this poise converts into Newton second per meter square, that is in SI system. 1 poise equal to 1 by 10 Newton second per meter square. Now this is converted into as a system. Viscosity is equal to 1 by 10 Newton second per meter square. This is we have. Then change in velocity du. Change in velocity du equal to, the velocity is given, initial velocity that over the plate is equal to 0, therefore final velocity 0.4 minus 0 is equal to, already I have explained regarding the change of velocity in the last problem. Therefore change of velocity is equal to 0.4 meter per second. This is also known to us. Then dy, the distance between the plates, that is given 0.15 mm. dy is equal to 0.15 mm, that is equal to 1.5 into 10 power minus 3 meters. Now all values known to us. Now we are going to determine the shear stress. Then tau is equal to viscosity of the fluid, that is 1 by 10 Newton second per meter square into change in velocity, that is equal to 0.4 meter per second, divided by distance between plates, that is given 1.5 into 10 power minus 3. Therefore shear stress equal to, from this equation, 266.66 Newton per meter square. This is the shear stress. Now we have determined shear stress, but we are going to determine what is the force. Already I have explained force equal to stress into area. Force equal to stress into area. Here stress we have determined, that is the shear stress. Therefore force equal to stress into area. Stress already determined here, but area is equal to given in the problem, that is equal to 1.5 into 10 power 6 mm square. First that converts into meter square. That means 1.5 into 10 power 6 mm square, that is divided by 10 power 6, that is meter square. Right? 1.5 into 10 power 6 mm square, that converts into 1.5 into 10 power 6 divided by 10 power 6, that is equal to meter square. Therefore force equal to stress, this is the stress, 266.66 into area 1.5 into 10 power 6 divided by 10 power 6. This is cancel. Therefore force equal to 400 newtons. This is the problem. Please note down the problem. Determine the intensity of shear of an oil having viscosity 1 poise. Viscosity is given, that is equal to 1 poise. The oil is used for lubricating the clearance between the shaft of the diameter 10 centimeters. The oil is used to lubricating the clearance between the shaft of diameter 10 centimeters. Shaft diameter is given, that is equal to 10 centimeter. And its journal bearing 10 centimeter, and its journal bearing, the clearance is 1.5 mm. That means dy is given, that is equal to 1.5 mm. And the shaft rotates at 150 rpm. Shaft rotates at 150 revolutions per minute. This is the given problem. Here determine the intensity of shear, that means what is the shear stress, what is tau. For the determination of tau, we know one standard formula, that is equal to tau is equal to mu into du by dy. But here viscosity is given, that is equal to 1 poise. Viscosity mu is given 1, poise, that is equal to 1 by 10 Newton second per meter square. This is in SI system. Now this is we have. What is the change in velocity? What is the change in velocity we are going to determine. In this problem, they have not given the velocity of plate or journal bearing. Now we are going to determine the velocity. But here they have given the speed given, that is equal to 150 revolutions per minute. If we know the speed of the shaft, we are going to determine the velocity, that is tangential velocity u equal to pi dn by 60. This is one formula for the determination of tangential velocity if they have given shaft speed n. Now this is equal to pi into diameter given, that is equal to 10 centimeter. 10 centimeter first, then that converts into meters. D equal to, right, D equal to 10 centimeter, that is equal to 10 divided by 100 meters. So 0 0 cancel, that is equal to 0.1 meter. Diameter of the shaft, that is equal to 0.1 meter. D is equal to 0.1 meter into n given in the problem, that is equal to 150 revolutions per minute divided by 60. Therefore tangential velocity, therefore velocity u is equal to 0.785 meter per second. Therefore u is equal to 0.785 meter per second. Right? Now we have the velocity, but now we are going to determine the change in velocity. Already I have explained to you how to determine the change in velocity. The velocity is 0.785 over the boundary, over the solid bearing, over the shaft. The velocity is 0. Right? Therefore the change in velocity is equal to 0.785. Then dy, this is clear. Then dy is equal to, what is the distance between shaft and bearing? That is equal to 1.5 mm. 1.5 mm. This converts into 1.5 into 10 power minus 3 meters. Now, therefore, tau shear stress equal to viscosity of the fluid, that is equal to 1 by 10 into change in velocity, that is equal to 0.0785 divided by distance between, or clearance is 1.5 into 10 power minus 3. Therefore shear stress tau is equal to 52.33 Newton per meter square. This is the shear stress. Right? Okay, now we are going to solve one more problem related to the viscosity. If the velocity profile of fluid over a plate is parabolic with the vertex 20 centimeter from the plate, this is one plate, the vertex 20 centimeters from the plate with the velocity is 120 centimeter per second. Velocity is given at the vertex, v is equal to 120 centimeter per second. Right? Calculate the velocity gradient and shear stress at a distance 0, 10 and 20 centimeters from the plate. If the viscosity of the fluid is 8.5 poise, viscosity of the fluid given mu is equal to 0.85 poise. They want to determine the change in velocity, that means du by dy at a distance 0 from the fixed plate and 10 10 centimeters from the fixed plate and 20 centimeters from the fixed plate. This is the first question. And another one, what is the shear stress that is at 0 distance and 10 centimeter distance and 20 centimeters distance. Now we are going to determine the velocity gradient over the boundary and 20 centimeters from the boundary and 10 centimeters from the boundary. And also we are going to determine the shear stress over the boundary, 10 centimeters from the boundary and also 20 centimeters from the boundary. For the determination of velocity gradient, first we should calculate the velocity. What is the velocity at a distance 20 centimeters from the plate? But they have given one hint, that is profile, velocity profile is parabola. Velocity profile is parabola. Therefore, u is equal to, velocity based on the parabola, u is equal to a y square plus b y plus c. This is the parabola equation. In this equation, a, b, c are the constants. These constants we are going to determine based on the boundary conditions. What are the boundary conditions? If the liquid is flowing over the boundary, there is a velocity gradient. I have already explained about the boundary conditions. Once again, the first boundary condition is, this is velocity profile. Now this is y is equal to 0 over the boundary. Y is equal to 0 over the boundary. Because of the viscous forces between the boundary and the liquid, velocity is equal to 0. And one more statement, if the distance from the boundary, y is equal to 20 centimeters, u is equal to maximum velocity, that is equal to 120 centimeter per second. This is second boundary condition. And third boundary condition, that at y is equal to 20 centimeters, that means at y is equal to 20 centimeters, at this point du by dy is equal to 0. Why du by dy is equal to 0? Over the boundary, the velocity is 0. This is the free stream velocity, 120 centimeter per second. But we are going to take here, this is the velocity. This velocity is less than 120 centimeter per second. Automatically we are having a velocity gradient here. If at a distance 20 centimeters from the fixed plate, there is no velocity gradient, there is only the free stream velocity, there is no change in velocity. The layer to layer, there is no change in velocity. This is the top layer, therefore du by dy is equal to 0. Three boundary conditions. Based on the first boundary condition, y is equal to 0, u is equal to 0. Now we are going to substitute these values in the parabolic equation. U is equal to 0, y is equal to 0, therefore in place of u we are going to take 0. 0 is equal to a, y is also 0, 0 square plus b into y is also 0 plus c. Therefore this is 0, this is also 0, this is also 0, therefore c is equal to 0. Now already we have determined the one constant, that is equal to c is equal to 0. Right, now we are going to apply second boundary condition, that is y is equal to 20 centimeters, the distance from the fixed plate, that is equal to 20 centimeters, velocity is equal to 120 centimeters, v is equal to 120 centimeters, 120 centimeter per second. V is equal to 120 centimeter per second. Now these values we are going to substitute in the parabolic equation. U is equal to 120 is equal to a into, what is the y value? Y is equal to 20 centimeters. 20 square plus, what is the b? Now we are going to determine b. b into y value is 20 centimeters plus c is already determined here, that is equal to 0. Now 120 equal to a, this is 400 plus b into 20, right. Now we are going to apply third boundary condition, that is equal to y is equal to 20, y is equal to 20 centimeters, du by dy is equal to 0. Now this equation differentiate with respect to y, therefore du by dy is equal to, this is 2ya plus b plus 0, right. du by dy is equal to 2ya plus b plus 0, right. Now we are going to apply the third boundary condition, y is equal to 20 centimeters, du by dy is equal to 0, therefore 0 is equal to 2 into y is 20 into a plus b. Okay, therefore from this equation b equal to minus 40a. b equal to minus 40a we have here. Now 120 equal to a into 400 plus b into 20. In place of b we are going to take the minus 40a. Okay, right. Therefore 120 equal to 400a plus, this is minus 40, therefore minus or plus minus 40a into 20. Just we have taken in place of b minus 40a. Therefore 120 is equal to 400a minus 800a. Therefore this is equal to minus 400a. Thus 120 equal to minus 400a, therefore a is equal to 120 divided by 400. Therefore a is equal to, this is minus, therefore a is equal to 0.3. Now a is equal to 120 divided by 40 minus 0.3. Now we have determined a is equal to minus 0.3. Then b is equal to minus 40 into 0.3, minus 0.3, minus cancel, plus right, minus 40 into minus 0.3, that means in place of a we have taken minus 0.3, this is equal to 12. Now we have determined a is equal to minus 0.3, b is equal to 12 and c is equal to 0, right. Now we want to determine what is the velocity gradient, at a distance 0, 10, 20 centimeters from the boundary. Therefore du by dy at a distance y is equal to 0. du by dy is equal to, what is the formula? 2yab. This is the 2ya plus Now du by dy at a distance y is equal to 0. That means over the boundary, that is equal to 2 into y value 0 into a plus b. What is the b value? Already we have determined. That is 12. Therefore du by dy over the boundary at y is equal to 0, that is equal to 12 units. Okay, next one, du by dy at y is equal to 10 centimeters. Same equation, 2ya plus b. Here 2 into y is 10 into what is the area? That is equal to minus 0.3. Minus 0.3 plus what is the b value? B is equal to 12. Therefore du by dy at a distance y is equal to 10 centimeter, that is the middle of the velocity profile. This is 10 centimeters. This is 20 centimeters. At the middle of the velocity profile, du by dy is equal to 6. 2 into 10 into minus 0.3 plus 12, this is equal to 6 units. Then, and again, velocity gradient at 20 centimeters. That means du by dy at y is equal to 20. Same formula, 2ya plus b. This is equal to 2 into what is the y value? 10 into 0.3 minus 0.3 plus 6. 2 into 10 into minus 0.3 plus 6. This is equal to 0. The velocity gradient at y is equal to 0, 12. The velocity gradient at y is equal to 10 centimeters, 6. Velocity gradient, that is du by dy at y is equal to 20 centimeters, so that is equal to 0. It indicates that the velocity gradient are du by dy at the top, that means 20 centimeters from the boundary, is equal to 0. Now we are going to determine the shear stress at y is equal to 0, that means over the boundary at y is equal to 10 centimeters, that is the middle of this velocity profile, and y is equal to 20 centimeters, that is 20 centimeters from the boundary. Therefore shear stress tau is equal to mu into du by dy. What is the mu value they have given in the problem? That is equal to 0.85 poise. That converts into 0.85 divided by 0.85 divided by 10 Newton second per meter square. Therefore this is equal to 0.85 divided by 10 Newton second per meter square into du by dy at y is equal to 0. Du by dy at y is equal to 0, already we have determined, that is equal to 12. Right? Right. Now we are going to determine the shear stress at y is equal to 10. That means here, what is the shear stress here? Therefore, shear stress at y is equal to 10. Shear stress at y is equal to 10, that is equal to same formula, mu into du by dy, that is equal to mu, that is equal to 0.85 divided by 10 into du by dy at y is equal to 10. Du by dy at y is equal to 10, that is equal to 6. This is equal to, that is equal to 5.1 Newton per meter square. And the last one, shear stress tau at y is equal to 20. Same formula, mu into du by dy, mu value 0.85 divided by 10 into du by dy at y is equal to 20. Du by dy at y is equal to 20, that is equal to 0 into 0, therefore this is equal to 0. And also the shear stress at y is equal to 0, 0.85 divided by 10 into 12, this is equal to, this value is equal to 10.2 Newton per cm square, 10.2 Newton per meter square, right? The shear stress at y is equal to 0, 10.2 Newton per meter square. Shear stress at y is equal to 10, 5.1 Newton per meter square, and shear stress at y is equal to 20 is equal to 0. It indicates that the shear stress at this point, that is the 20 centimeters from the boundary, the top layer, the shear stress is equal to 0. Because the shear stress we should have, there is a velocity gradient. Velocity gradient is equal to 0 at y is equal to 20 centimeters. Automatically shear stress is also 0 at y is equal to 20 centimeters from the boundary. Right? Right. Now we are going to solve some problems related to the surface tension. Please note down the problem. The surface tension of water in contact with air at 20 degrees is 0.0725 Newton per meter. Right, the surface tension of water in contact with air at 20 degrees is 0.0725 Newton per meter. The pressure inside a droplet of water is to be 0.02 Newton per cm square. 0.02 Newton per cm square. 0.02 Newton per cm square greater than the outside pressure. Calculate the diameter of the droplet of water. What is the diameter of the droplet of water? Now here in this problem they have given surface tension that is equal to 0.0725 Newton per meter, and pressure intensity given that is equal to 0.02 Newton per cm square. What is the diameter of the water droplet? In case of water droplet, I have given one formula, the relation between the surface tension and pressure inside the water droplet and diameter of the water droplet. That relation is sigma equal to PD by 4. P is the pressure intensity inside the water droplet, that is excess of the outside pressure, and D is the diameter of the droplet, and 4 is the value. Now in this problem we want to determine the diameter D, but here sigma is given, that is surface tension 0.0725 Newton per meter. This is in SI system. Okay. And another one, pressure is given, that is equal to 0.02 Newton per cm square. This converts into Newton per meter square. That is equal to 0.02 into 100 square Newton per meter square. Right? Now surface tension known to us, intensity of pressure is also known to us, only diameter is unknown. Now we are going to substitute the values in the equation. Now surface tension equal to 0.0725 is equal to intensity of pressure, that is equal to 0.02 into 100 square into D divided by 4. In this equation only unknown is D, therefore diameter of the water droplet D, diameter of the water droplet D equal to, from this equation, 0.00145 meters, or D equal to 1.45 mm. Right, this is the diameter of the water droplet. Please note down Another problem, the pressure outside the droplet of water of diameter 0.04 mm is, the pressure outside the droplet of water of diameter 0.04 mm is, D is equal to 0.04 mm. He is 10.32 Newton per meter square. That means outside pressure 10.32 Newton per, outside pressure equal to 10.3 Newton per cm square, not meter square, Newton per cm square. Right? The pressure outside the droplet of water of diameter 0.04 mm is 10.32 Newton per cm square. That is atmospheric pressure. Okay, calculate the pressure within the droplet. What is the pressure P within the droplet? Within the droplet, if surface tension is given as, that is equal to 0.0725 Newton per meter. Right here, in this problem, they have asked that what is the pressure inside the water droplet. For the determination of pressure inside the water droplet, I have given one relation, pressure and surface tension. Surface tension equal to PD by 4. Sigma is the surface tension, that is Newton per meter. P is the pressure intensity, that is only pressure intensity means, suppose this is the water droplet, the pressure intensity means that is in excess of outside pressure. Suppose the inside pressure is equal to 10 Newton per cm square. The inside pressure is equal to, the pressure intensity is equal to 10 Newton per cm square. But outside pressure, atmospheric pressure is equal to 10.3 meters of water. Now, the pressure inside the water droplet means the in excess of outside pressure. That means the pressure inside the water droplet is equal to 10 Newton per cm square, 10.33 meters of water. This is the pressure inside the water droplet. This pressure is nothing but, now we are going to determine the pressure inside the water droplet. Then that pressure added the outside pressure, add the outside pressure. Finally, we have the pressure inside the water droplet. But sigma is given, that is equal to 0.0725 Newton per meter. P is unknown, this we are going to determine here. D is given, that is equal to 0.04 mm, that is equal to D equal to 0.04 mm, that is equal to 0.04 into 10 power minus 3 meters. Right now we are going to substitute the values here. Sigma equal to 0.0725 equal to pressure intensity P into what is the diameter? 0.04 into 10 power minus 3 divided by 4. So here only unknown is P. Therefore pressure intensity P equal to 0.725 Newton per cm square. Pressure intensity P equal to 7250 Newton per meter square. From this equation, this is in SI system. This is also in SI system. Now we have the pressure intensity, that is equal to 7250 Newton per cm square. This converts into 0.725 Newton per cm square. Why we have converted like this? But the outside pressure they have given in the problem, that is equal to 10.3 Newton per cm square. Therefore the total pressure inside the water droplet equal to, small p plus outside pressure. That is equal to, what is the pressure determined here? That is equal to 0.725 plus outside pressure is given in the problem, that is equal to 10.32. Now therefore the total pressure in the water droplet is equal to 11.045 Newton per cm square. Right? Now we are going to solve one more problem related to the surface tension. Please note down. Find the surface tension in a soap bubble of 40 mm dia, D equal to 40 mm. When the inside pressure that is given, inside pressure 2.5 Newton per meter square, 2.5 Newton per meter square. The absolute pressure, above the absolute pressure, right? Find the surface tension in a soap bubble of 40 mm diameter. When inside pressure is 2.5 Newton per meter square, above the atmospheric pressure, find the surface tension. What is the sigma? Sigma equal to what? I have derived the relation between the surface tension and pressure inside the soap bubble. That is sigma equal to PD by 8. This equation already I have derived in the earlier class. Now here we want to determine sigma, pressure inside the water droplet in excess of the outside pressure, that is given 2.5 Newton per meter square, and diameter is given, that is equal to 40 mm. Therefore D equal to 40 mm, that converts into meters, 40 into 10 power minus 3 meters. Therefore surface tension sigma equal to what is the P value? 2.5 Newton per meter square into D, that is equal to 40 into 10 power minus 3 divided by 8. Therefore sigma equal to 0.0125 Newton per meter. Right? These are the problems related to the surface tension. Now we are going to discuss about some problems related to the capillarity. Please note down the problem. Calculate the capillarity rise in a glass tube of 2.5 mm diameter. When immersed vertically in a water, question number 1, in a water, immersed vertically in a water, and question number 2, that is in mercury. Right? Take surface tension sigma equal to 0.0725 Newton per meter. This is for water. And sigma equal to 0.52 Newton per meter for mercury in contact with air. For mercury in contact with air. The specific gravity for mercury is given as 13.6. Specific gravity of mercury given 13.6. And angle of contact with air, that means theta is given, that is equal to 130 degrees. But here I have derived one equation. If the glass tube is immersed in water, the capillarity rise H is equal to, I have derived one equation. If the glass tube is immersed in mercury, capillarity fall is equal to, I have given one equation. Now if the glass tube is immersed in liquid, the capillarity rise H is equal to 4 sigma cos theta divided by rho g d. This is the formula I have derived in the earlier class. Sigma is nothing but surface tension of water. If the glass tube is immersed in liquid, then only this is the formula for the determination of capillarity rise, HR equal to 4 sigma cos theta by rho GD. In case of water, if the glass tube is immersed in liquid, the contact between the water and glass tube theta equal to 0, because the water, if the pure water, theta equal to 0. Now sigma value given, sigma for the water is equal to 0.0725 Newton per meter, cos theta, theta is equal to 0, rho, density of water we know that is 1000 kg per meter cube, g equal to 9.81, and d equal to, diameter is given, d equal to 2.5 mm, that is equal to 2.5 into 10 power minus 3 meters. Now we are going to substitute the values here. Capillarity raise equal to 4 into, what is the sigma? Sigma, that is surface tension for water, is equal to 0.0725 into cos theta. Theta is 0 in case of glass tube immersed in water, right? Divided by rho is nothing but water density of liquid, density of standard liquid or water is equal to 1000 kg per meter cube into G value 9.81 into diameter is equal to 2.50 into 10 power minus 3, right? Therefore the capillarity raise is equal to 7.5 mm. Therefore capillarity raise is equal to, this converted into 7.5 mm. This is the capillarity raise. Now if the glass tube is immersed in mercury, capillarity fall is equal to, same formula, 4 sigma cos theta divided by rho GD. Here only the difference is the contact angle between the glass tube and water is different. Theta in case of glass tube is immersed in mercury, the theta is equal to 130 degrees. This is equal to 4 into sigma for mercury is also different. That is given, surface tension for mercury is also different, that is 0.52 Newton per meter. Sigma equal to 0.52 Newton per meter into cos 130 degrees divided by rho is nothing but density. Density of water is equal to 1000 kg per meter cube. Density of mercury is equal to specific gravity of the mercury into density of the standard liquid. That means specific gravity of the mercury given, that is equal to 13.6 into density of the standard liquid, that is equal to 1000 kg per meter cube. That is the rho value into G value 9.81 into D, diameter is given, that is equal to 2.5 into 10 power minus 3. Therefore capillarity fall H is equal to minus 2.450 mm, right? Last problem, small mistake here. The capillarity raise is equal to 0.118 meters. The capillarity raise is equal to 0.118 meters. That is equal to 1.18 centimeters. And capillarity fall is equal to minus 0.4. This is equal to minus 0.04 meters. That is equal to minus 0.4 centimeters. This is the capillarity fall, this is the capillarity raise. Please note down small problem. Calculate the capillarity effect in a milli mm in a glass tube of 4 mm dia. D is equal to 4 mm when immersed in water and mercury, that is water and mercury. The temperature of the liquid is 20 degrees centigrade and the value of surface tension for water is equal to water and mercury at 20 degrees centigrade in contact with air, or for water sigma is equal to 0.07357 Newton per meter, for mercury 0.51 Newton per meter respectively. The angle of contact of water is 0 and that for mercury is 130 degrees. Theta for water is equal to 0, theta for mercury is equal to 130 degrees. Take the density of water at 20 degrees temperature is equal to rho equal to 998 kg per meter cube. This is the different. Same standard formula, capillarity raise, if the glass tube is immersed in water, capillarity raise is equal to 4 sigma cos theta divided by rho GD. This is equal to 4 into sigma for water is given, that is equal to 0.0735 into cos theta. This is 0 divided by density of water. But here density of water given at a 20 degrees temperature 998 kg per meter cube. Not we are going to take in 1000 kg per meter cube, because at 20 degrees temperature the density of water is given, liquid is given, that is equal to 998 kg per meter cube. 998 into G value 9.81 into diameter of the glass tube is given, that is equal to 4 mm, that is equal to 4 into 10 power minus 3 meters. This is the diameter, 4 into 10 power minus 3. Therefore capillarity raise 7.5 centimeters. Now capillarity fall, HR is equal to, if in case of mercury same formula, 4 sigma cos theta divided by rho GD, 4 into sigma for mercury, that is equal to 0.51 into cos theta, theta here that is equal to 130 degrees, divided by rho, density of mercury here, that is density of the liquid at 20 degrees temperature, that is equal to 998 in specific gravity of the mercury is given 13.6 into G value 9.81 into D is equal to 4 into 10 power minus 3. Therefore capillarity fall equal to minus 2.4 mm. Therefore capillarity fall is equal to minus 2.4 mm. Only the difference is earlier problem we have taken 1000 into 13.6. If the standard liquid density is equal to 1000 kg per meter cube, here at 20 degrees temperature the density is given, that is equal to 998 kg per meter cube. Therefore 998 into 13.6. Right, thank you one and all.